when you look up at the night sky and see the moon shining bright. Have you ever wondered why it glows and what causes its different phases? The glow of the moon and the changes it goes through during its phases are not just beautiful natural phenomena, but are deeply tied to the laws of space and the relationship between the moon, Earth, and the sun. Let's delve into these mysteries and make sense of how they work. The moon, unlike the sun, does not produce its own light. Instead, the glow we see is sunlight reflecting off its surface. This might sound simple, but it's quite an intricate process. The surface of the moon is covered with a layer of dust and fragmented rock called regolith, which is made of silicate minerals. This rocky surface reflects sunlight, which makes the moon visible from Earth. However, the moon's surface doesn't reflect light as efficiently as a mirror. Its albedo, or reflectivity, is around 12%, meaning only 12% of the sunlight that strikes it gets reflected. But even with this modest reflectivity, the moon still appears bright to us because of its proximity to Earth. Now, when we think about the phases of the moon, new moon, crescent, first quarter, full moon, and so forth, they're not just random changes. These phases are caused by the relative positions of the Earth, Moon, and Sun. As the moon orbits Earth, the angle at which sunlight strikes it changes, altering how much of its illuminated half is visible to us. It takes about 29.5 days for the moon to complete a full cycle of phases. When the moon is directly between Earth and the sun, we see a new moon. This is when the side of the moon facing us is in shadow. As it moves along its orbit, a sliver of light appears, leading to the waxing crescent phase. This light grows into the first quarter, where half of the moon is illuminated. Moving further, we reach the waxing gibbous phase, where more than half of the moon's face shines. The full moon follows, when the entire face of the moon is lit by the sun, creating a brilliant display in the sky. After this, the process reverses, transitioning to the waning gibbous last quarter, and finally the waning crescent, before starting again as a new moon. The moon's phases are only part of what makes it fascinating. The moon rotates on its axis at the same rate that it orbits Earth, a phenomenon called synchronous rotation. This is why we always see the same side of the moon from Earth, known as the near side. The far side, often mistakenly called the dark side, is not permanently dark, but simply not visible to us because of this rotational lock. This synchronization occurred due to tidal locking. Over millions of years, the gravitational pull between Earth and the moon slowed the moon's rotation until it matched its orbit. This effect also influences Earth. The moon's gravitational force affects the Earth's oceans, creating the high and low tides we experience. Without the moon's steadying influence, Earth's axial tilt would vary more wildly, leading to significant shifts in climate. In addition to these everyday effects, the moon presents some special events. Take the supermoon, for instance. When the moon is at its closest approach to Earth, known as perigee, and coincides with a full moon, it appears larger and brighter, hence a supermoon. Another awe-inspiring sight is a lunar eclipse, which occurs when Earth comes between the sun and the moon. This alignment causes Earth's shadow to fall on the moon, temporarily dimming it and often creating a deep red color due to the refraction of sunlight through Earth's atmosphere. There are also rare occasions like the blue moon, which has become synonymous with something that rarely happens. Contrary to what its name suggests, a blue moon doesn't appear blue. It refers to the occurrence of a second full moon within a single calendar month, happening roughly every 2 to 3 years. Space science has significantly advanced our understanding of the moon. The Apollo missions of 1969 to 1972 were landmark achievements that allowed humans to set foot on the moon and bring back samples for study. These missions not only proved that the moon was formed from material shared with Earth, supporting the giant impact hypothesis, but they also demonstrated how the moon's surface had been shaped over billions of years by meteor impacts and space weathering. Space weathering is a process where micrometeorites and solar wind alter the moon's surface over time, giving it its characteristic grayish tone. The moon's significance doesn't stop at scientific curiosity. It plays an essential role in human culture and history. Stories, myths, and legends have been crafted around its glow and phases, underscoring its universal fascination. The moon has inspired everything from poetry and art to ancient calendars that mark time by its cycles. As humanity looks to the future, space exploration programs like NASA's Artemis aim to return humans to the moon and study its south pole, where scientists believe water ice exists in permanently shadowed craters. The presence of water could be a game changer for establishing a long-term human presence on the moon and as a stepping stone for deeper space exploration. The moon, a familiar beacon in our night sky, embodies a complex interplay of gravitational forces, reflected light, and orbital dynamics. Its phases are reminders of the dance between celestial bodies, and its glow tells a story of reflected sunlight, distant impacts, and billions of years of cosmic history. Every time we see the moon, whether as a thin crescent or a bright full circle, we are witnessing a testament to the forces that govern our universe.